Hello. So let's discuss a little bit about Pascal's triangle. And this is a method for what we call a kind of a binomial expression. Remember, binomial means two kind of expressions into a parenthesis. And it's really a triangle arrangement. Um, Before Pascal, I will mention that in a little bit. But the Chinese mathematician Jin Gong, I think that's how you would say that, pronounce that, during the 11th century came up with kind of the same idea to calculate something to really break down or break apart a binomial expression to some power. Remember, n is going to be to some power. So it could be to like the second power, third power, fourth power. And without writing this four parentheses and doing FOIL or the box method so many times, there's a, a way that we can make it a little bit easier with knowing what we call Pascal's triangle today. And so that's kind of where we're going. So it's named after Blaise Pascal. He lived around 1623. He was a physicist and religious philosopher back in his day. He was born in France about 1623. His mother passed away when he was young. He came pretty much. He was just a young person in that time because his parents just kind of deceased. He became interested in geometry around age 12, and he taught himself quickly about the properties of figures in geometry. Remember Euclid's Elements, it was a big part of this, and that was the big foundation by then. And so he, by age 14, he was um, he was kind of he was going to an academy. The French academy is kind of like maybe like a college, you can call it there. Um, but he was a really brilliant kind of a person back in his day, and he didn't really live that long. So that's kind of bizarre. Um, there was a lot of diseases back then. People didn't really live that long. We didn't have the medicine like we do today. But enough of that. Let's go ahead and discuss what we call Pascal's triangle. So remember that you have this binomial expansion. So for example, let's start with something to the second power. Now we have this binomial expansion, and if we want to extend this, the old-fashioned way is to write it twice, and go from here and use what we call FOIL, or maybe the box method, depends on how you learn it. A lot of us use FOIL. And so if you did this FOIL, you would go, this times this, which is x squared, this times this, which is xy, this times that is still xy, and this times this is y squared. Then you just combine like terms in here, and you have x squared plus 2xy plus y squared. And that's what you get when you do the square. That's great. We can do that. But we have a problem. It's very time consuming when we get to something like to the third power, to the fourth power, to the fifth power, to the sixth power. That becomes an issue because it becomes time consuming. And so a way to kind of remember this, or maybe to kind of lighten the work a little bit, we are going to go to what we call Pascal's triangle, this triangular arrangement of these binomial expressions. So here's what we're going to do. We're going to kind of look at that. So let's go ahead and make a triangle. And we're going to go start at 1. 1's at top. 1, 1. 1, add these two. So you're going to add these two, that'd be 2. 1. 1, add these two, you get 3. Add these two, you get 3. 1. Put a 1. Add these two, you get 4. Add these two, you get 6. Add these two, you get 4. 1. Put a 1. Add these two, you get 5. Add these two, you get 10. Add these two, you get 10. Add this 5 and 1. And it just keeps on repeating for forever. So what I'm going to put on the side here is kind of what does this mean? What is this kind of representing? So kind of looking at here, remember that if you had, let's say, x plus y to the, let's say, 0 power, remember that is just a plain and simple 1. Anything to the 0 power is 1. Well, that's kind of the true thing with this one. To the first power, it's just x plus y. That's what that means. Well, now you're going to get into like what we call the second. Well, that's kind of when we have this, to the second power. What I want you to do is kind of take this one and look up here. This one up here at the tippy top, wasn't that squared? But now I want you to look at our answer here. So that was squared. So we do that process, we get this. Well, what if we go down here and look at these, look at the coefficients. So look at the coefficients. We have 1, we have 2, and we have 1. Do you see them? So I have an idea or a question. What if we had x plus, and by the way, we could have minus here too, but just to make the math simpler, let's just use positives, but let's go to the third power. And so the third power is going to have these coefficients. Well, what about here? X plus y to the fourth power. Well, that's going to have these coefficients. And do you see that? Do you see this number right here? Do you see this number? Do you see that? Do you see this number right here? Do you see this number right here? Do you see this number right here? That's what it socializes. So this is going to be 5. So there's your breakdown. So let's do a couple examples and maybe we can kind of see what we can do. So let's go ahead and just make one up. So what if I wanted to do x to, let's use some positives to the fourth power. That is hectic to do that. I don't want to do the FOIL 4 times. The thing was going to be, it's going to be terrible. But if we know Pascal's triangle, we can actually do this a lot easier. And by the way, these are coefficients of 1. They could be 3, they could be 4, they could be 5, they could be 6, but it makes the numbers kind of easier. So just for us. So we're going to go to the fourth power. So I need to kind of see, what would it be looking like? So I'm going to make the triangle. I'm going to go 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I'm going to stop right here because that's the fourth power. These are the coefficients. So these are the coefficients I want to use. So what I'm going to do is kind of take these coefficients and write this out. So I'm going to use this one right here. Well, if I do this, that is technically 1. But that's x to the fourth power. And what I'm going to do, everybody, is I'm going to put a y to the 0 power. And why? Anything to the 0 power is 1. Right? Anything to the 0 power is 1. So I can do that. Well, we are still adding. So we're going to go 1. Then I'm going to use this 4. So that's going to be 4x. But you see how this is a 4? Let's write this one as a 3 because it's going to decrease. But if that's a less than 1, what about this one here? Well, why don't we increase? So let's decrease the x's, increase the y's. Decrease the x's, increase the y's. Keep going. We have a 6. Plus 6x squared, y squared. We have a 4. 4x, x to the first, y to the third. Plus, remember this is x0. I'm going to write it just because. Y to the fourth. Now, do you see the significance? This is what it would look like if you were to extend this out 4 times. I mean, you can go back and you can do this FOIL 4 times, you will see that these are the numbers. So I'm going to clean this up a little bit, if you don't mind. So I'm going to kind of clean this up so we don't have all this extra material in here. And that's going to be your problem. I also want you to focus on one additional thing. Look at the degrees. Notice the degrees. There's a 4. Well, that's a 4. Add, what's the degree here? Isn't there a 1 right there? What if you add? What if you add these? Don't you get 4? What if you add these? Don't you get 4? What if you add these? Add the two exponents and 4. Do you see that? So that's another characteristic out of this. That's why it makes it so kind of fun. Let's go ahead and do one more, but I'm going to change some numbers here. So it's going to be kind of chaotic. So I'm still going to use positive. I know that's really a lot of positive, so these can be negative. And just to make this video simpler for you, let's go ahead and use 2x plus, I don't know, let's do 3y. And let's do 5, because that's a good one. Now, you can do FOIL 5 times. You're going to have a headache. You can do it. Be very careful. But if we know Pascal's triangle, this will be a breeze. So let's do that. So Pascal's triangle, we're going to go up to the 5th power. So here we go. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. I'm experienced, so this is why it goes fast. So we're going to hit here because this is the 5th power. Do you see how these numbers match the powers? So these are kind of like your power, your powers you want to go to. So let's go ahead and do this one. So first off, we have a 2. So we have a 1 times 2. If you don't mind, I'm going to kind of skip 1, but I'm going to write the 2. So this is going to be 2x to the 5th power. Okay, so that one's done. And if you want to, you could put a y to the 3rd power. It doesn't matter. It's up to you. Okay, keep going. So positive. And then I'm going to go 5 times 2 is 10. So that's going to be 10 to the 4th. Then you're going to put the 3. So 3y to the 1st. The exponent should add to 5. Okay, keep going. Positive 10. 10 times 2. If you want to, we can maybe we can modify this before we do this. So if you would like to, we could modify this, but you know what? I'm going to keep it simple for us, if you don't mind. So 5 times that is going to be, I'm sorry, 2 times 10 is 20, my fault. X to the 3rd times 3 to the y squared. Look at the exponents. Okay, keep going. 10 times that is still 20. X squared, 3 y to the 3rd. Look at the exponents. Plus, we're here, 5 times that is 10. X to the 1st, you don't have to write that, times 3y to the 4th. Look at the exponents. Plus 1, which is technically 1 times 2 is 2x to the 0. I'm just going to put it for now. And y to the 5th. So I'm going to clean this up a little bit. So this is 2x to the 5th plus 10x to the 4th times 3y plus 20x to the third times 3y squared plus 20x to the third times 3y to the third, oops, squared, plus 10x y to the, 3y to the fourth, look at the exponents, plus, we can kind of ignore this one, so that would be 2y to the fifth. Now, what we could do, we can multiply these numbers together, but I think that the important thing I want you to take away is the how to break down the Pascal's triangle a little bit. All right, so there's kind of a way to kind of do these. I'm just trying to make this video short for you. There is a lot that you could try, so a few that you could kind of try on your own is maybe like x plus 2 to the fifth power. Try this one. You can also say 2a plus 1 to the third power. Maybe we want to try a minus 1. Okay, that one's kind of pretty straightforward, but maybe we can test this out a little bit. Maybe make to the third power, just kind of see if we can do it. So I think that maybe trying those and see how the Pascal's triangle, but it's pretty straightforward. So one more time, the Pascal's triangle, start with 1, 1, 1. Add those two, 1, 1. Add those two, 1. 1, add, 1. Add, 1, add, 1. Let's go to 6. 1, 6, that's 15. Oops, 20, 15, 6, and 1. And you can keep on going. But these are the degrees, remember, these are the degrees. So if you see something like x plus to the 6th power, those are the coefficients there. And there's other ways of looking at this too and using this, but we're starting off a little bit, just kind of seeing how you're doing. All right, hopefully that is kind of an interesting aspect for you. So please make sure that you look at this and see what you can do. All right, thank you.